Today, we're going to go underground. We're diving into a world that, keeps our cities running, but we almost never see. It's a world of drains and sewers, and for the people who work there, it is an incredibly dangerous place. But it's also where a story of some amazing innovation is unfolding, where a new generation is literally building the future of sanitation, one robot at a time.
So here's how we're going to break it all down. First up, we're going to face the really harsh reality of this dirty, dangerous job. Then, we'll take a look at the old school methods, how things are currently done. After that, we get to meet the real heroes of the story, the drainage droids. We'll even peek inside the robot's brain to see how they tick. And finally, we'll explore the innovation playground where these incredible ideas are actually born. All right, let's just get right into it. Because before we can really appreciate how revolutionary this new tech is, we have to understand the very real, very human cost of the problem it's trying to solve. 23,000. That's not just some abstract number. Research into sanitation work in India estimates that's how many men and women die every single year doing this job. Just let that sink in for a second. 23,000. And if that last number wasn't shocking enough, look at this. This statistic brings it all into even sharper focus. We're not just talking about accidents. No, this is about a lifetime of exposure to toxic fumes and hazardous materials, leading to diseases that tragically cut lives short. A staggering 80% of these workers don't even make it to age 60.
So what's at the heart of this crisis? It's a practice called manual scavenging. And get this, it was officially banned in India way back in 1993. But the reality is, when machinery breaks down or can't do the job, humans are still sent down into these sewers to clear blockages by hand. This is the exact problem that so desperately needs a better solution.
So you might be asking, if manual cleaning is so incredibly dangerous, what are the alternatives? Let's take a look at the existing tools of the trade, the methods we're using right now to fight clogs without sending people down into the pipes. Okay, so there are basically two main techniques. First, you've got mechanical rodding, which is pretty much exactly what it sounds like. A long, flexible metal rod gets pushed into the pipe to physically break up whatever's blocking it. And then there's the more modern way of doing things, high-pressure jetting, which just blasts clogs apart with a super powerful stream of water. And you can really see the difference between these two methods right here. Rodding, well, it's pretty much a Band-Aid solution. It targets that one immediate clog, but it can leave a lot of gunk behind and can even scrape up and damage older pipes. High-pressure jetting, on the other hand, is way more thorough. It gives the pipe a full 360-degree cleaning, which doesn't just clear the clog, but actually helps prevent new ones from forming. It's for sure the better choice, but it's still just a tool that needs a human operator right there in that dangerous environment. But what if? What if we could take the human out of that dangerous equation almost entirely? Now, this is where the story gets really, really cool. It's time to meet the drainage droids. This is a robotic revolution being built quite literally from the ground up. And here they are. Now, look, these aren't some sleek, multi-million-dollar machines from a giant corporation. They are rugged, functional prototypes. I mean, you can see the exposed wiring, the simple frames. These were built by engineering students in India who looked at this deadly problem and just decided, hey, we can engineer a better, safer way to do this. So why robots? Well, their design has one single primary goal: to save lives. It's that simple. They completely eliminate the need for humans to go into the sewers. They can be operated safely from a distance, and they're built to handle the exact solid waste and toxic materials that cause all those terrible health problems. These robots are a direct answer to the crisis we were just talking about. Okay, so how do they actually do it? This isn't science fiction, believe it or not. It's a really clever combination of off-the-shelf parts and some brilliant programming. Let's take a look inside the robot's brain. At the very heart of the machine is an Arduino Uno microcontroller. The easiest way to think about it is like the robot's central nervous system. It's what takes in all the information from the sensors and then sends out commands to the motors and tools, coordinating every single move. Right, so it can follow commands. That makes sense. But what gives it that next-level intelligence? What actually makes it a smart robot? Well, the answer is computer vision. And this is the really cool part. The robot's camera can actually recognize and interpret human hand gestures. So an operator can literally point to tell it where to go or what to grab, and the robot just understands. This gives them incredibly precise, intuitive control over all its tools. And the best part? All of that control happens from a safe distance. Using common platforms like Blink IoT, these students built simple mobile apps. So right from a phone screen, an operator can drive the robot, use its cleaning arm, and see its exact GPS location, all while staying safely above ground. It's brilliant. You can actually break the whole system down into 4 simple parts. You've got the brain, that's the Arduino. Then you've got the senses, it's sensors that help it see walls and know where it is. Next are the muscles, the motors that make it move. And finally, you've got the hands, the robotic arm or shovel or blade that does the actual dirty work. A brilliant invention is one thing for sure, but creating a whole culture of innovation, that's something else entirely. So where do these incredible student projects even come from? Well, they're born in what you might call an innovation playground. And a huge part of what fuels that playground is good old-fashioned competition. This chart just shows a few of the prize pools from Kshitij, which is this massive tech festival at one of India's top engineering schools. We're talking about some serious prize money for events like RoboWars and Sand Rover, competitions that really push students to design, build, and operate these kinds of remote-controlled machines. So what this all means is that our drainage droids didn't just appear in a vacuum. Nope. They're the direct result of this vibrant ecosystem that actually encourages and rewards hands-on engineering and creative problem-solving. These tech feasts create the perfect environment for students to apply what they're learning to huge, real-world challenges. Which really leads us to a final, pretty powerful question. If a group of determined students, armed with affordable tech and driven by this amazing competitive culture, can create a real solution for a problem as old and as dangerous as sewer cleaning, what's next? What other massive civic challenges are just sitting there, waiting for a solution to be built not from the top down, but from the ground up?